Let us now look at Archimedes. We see that we have created an experiment called power windmill. Let us see how it has been defined. So let's click on it. We see that it has one control parameter, which is the wind speed, one input parameter, which is the diameter of the windmill, and one output parameter, which is the electric power. What this system represents is the consolidated windmill plus generator system. The input is the wind speed and the output is the electricity. If we look at results which have been loaded for this experiment, we see that we have loaded results for the 30-inch diameter windmill. So let's look at the results by clicking on it. Let's plot the electrical power output with relation to the wind speed. I would like to remind you that these results have come from the Bluecanoe simulation that we ran earlier. Let us now see how we can reuse these results to create a more complex system in Bluecanoe. We want to add a wireless antenna to our wind power station so we can have a wireless tower which can route internet traffic. The electricity generated by the wind power station will power the antenna. The goal is to have such wind powered wireless stations at regular distances on the highway so that they can communicate with each other and provide internet bandwidth to cars which are traveling on the highway. If we look at Archimedes, we see that we already have an experiment which contains the data for a wireless station. And let's look at this experiment, what it does. So it has an input for the power of the antenna, the distance between consecutive wireless stations, and the effective bandwidth that it will support. Our goal in this part of the demo is to see what will happen if we power the wireless stations with electricity generated by a windmill. If we go to Bluecanoe, we see that we have already defined such a system, which is a wind powered wireless station. Let us click on it to see how it has been configured. We see that it contains two subsystems, the power windmill and the wireless station. Let us click on each one of them and see how they have been configured. We see that the power windmill subsystem points to the power windmill experiment which we created in Archimedes by recycling results from the previous Bluecanoe simulation. We see that none of its parameters are wired. Let us now look at how the wireless station is configured. Let's click on it. We see that it points to the wireless station experiment in Archimedes. We also see that its power parameter is wired to the electrical power generated by the windmill. Let us now run the simulation. It takes like a second to run, and let us now look at results. We see how the effective bandwidth of such a wireless station would change with the wind speed. We see that there is almost no bandwidth until the wind speed reaches something like 30 or 40 miles an hour. This is not a very useful solution in real life, so let us see if there is anything we can do to make this a more practical system. But before we do that, let us move the results of this simulation into Archimedes so that we can use it for the next more complex solution that we create. If we go back to Archimedes, we see that we have already created such an experiment. So let us click on it to see how it looks. Here we see that it has one control parameter, which is the wind speed, the diameter of the windmill, and one output parameter, which is the effective bandwidth of the wireless station. Let us now look at results. we see that we have already uploaded the results for the 60-inch diameter windmill for this experiment. So let us see what the results look like. Here we see how the effective bandwidth varies as a function of the wind speed. Once again, I would like to remind you that these results came from the simulation that we just ran in Bluecanoe. Let us now see how we can use these results to create a more complex system to ameliorate the problem where we do not have any bandwidth for low wind speeds. We can increase the speed of the wind hitting the fan of the windmill by using a nozzle. A nozzle is simply a cross section of a cone, and it increases the speed of the wind passing through it by Bernoulli's principle. So in the system that we develop next in Bluecanoe, we'll put a nozzle in front of our wireless wind power station. The wind speed will be an input of the nozzle. The output of the nozzle is high speed wind, which will then be fed into the windmill, and we'll see how much bandwidth is generated by a system such as this. If we go back to Archimedes, we see that we already have an experiment for a convergent nozzle. Let us click on it to see what it looks like. We see that it has a single control parameter, which is the input wind speed, and it has a single output parameter, which is the output wind speed. Let us now go back to Bluecanoe, where we see that we have created a system for our wireless windmill, this time with a nozzle. So let me click on it and we can look at its subsystems. We see that it has two subsystems, the nozzle and the wireless windmill. Let us click on them to see how they are configured, starting with the nozzle. We see that it points to the convergent nozzle experiment in Archimedes. We also see that it does not have any wired parameters. Let us now see how we have configured the wireless windmill by clicking on it. We see that it points to the wind-powered wireless station experiment which we just created in Archimedes. We also see that the wind speed parameter has been wired to the output wind speed of the nozzle. This means that the wind speed which will drive our windmill will come from the outlet of the nozzle. Let us now run the simulation by clicking Simulate. We see that it takes a second to run the simulation. Let us now look at the results. Let us select the effective bandwidth output parameter and plot the results. So now we can see how the effective bandwidth will vary as a function of the input wind speed for this new system. We can see that for this system we get a decent bandwidth even at wind speeds as low as 4 miles per hour, and when the wind speed goes to 6 miles an hour we get over 1 Mbps bandwidth. This is an excellent system. Of course this is only a simulation. We do not know how it will work in real life unless we go and do laboratory tests and field tests. In any case, what we have learned is how to consolidate systems in Archimedes by bringing in values from Bluecanoe and recycling them to create more and more complex systems.